Hi class, today I want to talk about volumes, but I want to give you two examples. The first example, you will see the cross sections is a disc, which is like a solid disc. The second example, the cross section is going to be a washer. So it's like a ring, like a donut. So let me share the problems with you. So example, we want to find the volumes of a solid obtained by rotating the regions bounded by x cubed and the horizontal line 8 and x equal to 0 about the y-axis. Now, this is interesting because in the last video, everything I did, the cross sections is created by rotating the x-axis. But this time we want to do it for y. We want to rotate about the y-axis. Now, if you rotating about the y-axis, it has to be perpendicular to y. And so we're going to have to change everything. We're going to have to integrate in terms of y. All right. So let's take care of the disk first, right? So the disk we have so remember we slice the solid perpendicular to the y-axis. Okay, so x, you see we have y equals to x cubed. I'm gonna have to solve for x now. So x is gonna be cube root of y. Okay, so the area of the cross sections, once again, we're dealing with area of a circle. So now I'm going to put a y, right? A of y. And remember, area is pi r square, right? So in this case is pi x square, okay? X is the radius, okay? So r square means x square. Now, we got that x equals to cube root of y, so I'm gonna change it in terms of y, so it's gonna be cube root, right? And then I square it, so it's gonna be pi y 2/3. Okay, so make sure you remember we're dealing with dy now. Okay, so the volumes, I'm going to take the volumes now. The volume is going to be from 0. Oh, by the way, we're dealing with y, right? So it's not going to be, so you have to change it. You have to go from 0 to 8. How do I know it's 8? It's because of this. It's that one. It's bounded, right? It's bounded from 0 to 8. So that's why. Okay. So we have ay dy. Now I just have to plug it in. So the volume is going to be from 0 to 8 pi y 2/3 dy. We take the antiderivative. I can take pi out. It's going to be 3/5 y 5/3, and we go from 0 to 8. So we ended up with 96 pi over 5. So that's the volume. Okay. All right. Moving on to example 4. Example 4, you can see that we want the regions enclosed by the curve y equals x is that one. And then y equals x squared is the parabola, right? Now we want to rotate it about the x-axis. So we are back to dx. Anyway, so how do we create that cross section. You can see that if I slice it, if I slice just that part, you see it's not touching the x-axis, and I rotate it, it's turned into a washer. You see that? And then, so you take that piece, you rotate it, so you can see that the outer circle is has the radius of x, right? And the inner circle has a radius of x squared. Okay, so hopefully you can recognize the cross sections right there. Now, one important thing is the points of intersection. So let's take care of that, right? So you see I have the graph for you right there. So the points of intersections is 0, 0 and 1, 1. Okay. Anyway, if you don't want to use the graph, you can definitely put them together like this. X equals x squared, right? And then how do we solve it? I can just put x squared minus x equals x, and then x minus 1 equals 0, right? So we have x equal to 0 and x equals to 1. So like I said, we can just solve it easily. Anyway, now notice that the cross-sectional area we have is going to be the area of the outer circle subtract the inner circle. So outer minus the inner. Okay, so how do we figure it out? I told you earlier, we have the outer is x, right? The outer is x. The outer is, I shouldn't put this, so when you put area like that, I should go like this. So outer is the x1. The inner is the x squared. All right, notice that we're dealing with area, and area is pi r squared, right? So I have pi, r is x squared, minus pi r squared. Okay, so you don't get confused. So I can take pi out. So the area of the cross section is going to be pi x squared minus x to the 4th. Now we can use it and plug it in for the volumes. So the volumes is going to be from 0 to 1. We're dealing with x, okay? So you pick the x values. We have pi x squared minus x to the 4th dx. And then we just integrate it. X cubed over 3 minus x to the 5th power over 5. You go from 0 to 1. So it's going to be 2 pi over 15. That's the volumes. Okay, so as you can see, we have a donut here, we have a washer here. The previous problem, we have a disc. So we just have one circle. For the washer, you have the outer circle minus the inner circle to have that curve right there. Okay,